The fascinating history of wormholes. The concept of wormholes, theoretical passages through spacetime that might allow for shortcuts between distant regions of the universe, has captivated the minds of physicists and science fiction enthusiasts alike for decades. While their potential for enabling faster-than-light travel and time travel is intriguing, wormholes also challenge our understanding of the fundamental nature of space and time. To truly appreciate the allure of wormholes, it is essential to explore their origins, evolution, and some of the most fascinating facts associated with them. The birth of the idea, 1935, Einstein and Rosen. The idea of a wormhole can be traced back to 1935, when two renowned physicists, Albert Einstein and Nathan Rosen, introduced the concept of the Einstein-Rosen bridge in a paper titled The Particle Problem in the General Theory of Relativity. The paper was an attempt to explain the behavior of light and matter in the framework of general relativity, Einstein's groundbreaking theory of gravity. Einstein and Rosen found a solution to the field equations of general relativity that described a peculiar structure, which they described as a bridge between two separate points in spacetime. This bridge was what we now refer to as a wormhole. However, in their initial work, Einstein and Rosen didn't conceive the bridge as something that could be used for travel. Instead, they saw it as a mathematical curiosity, a way to describe the nature of space itself. Over time, their work would lay the groundwork for future investigations into the potential practical uses of wormholes. The expanding idea, 1950s and 1960s. In the 1950s and 1960s, the notion of wormholes began to gain more attention from the scientific community, particularly among physicists studying spacetime geometry. The theoretical foundations of wormholes were expanded by notable scientists like John Archibald Wheeler and Kurt Gödel. Wheeler, in particular, was instrumental in popularizing the idea of wormholes and linking it to the possibility of time travel. It was during this period that the concept of traversable wormholes emerged, wormholes that could, in theory, allow for the passage of matter or light. The idea was further popularized by Carl Sagan and other science fiction authors, who imagined how such shortcuts could be used for interstellar travel. Modern theory and popularization, 1980s and beyond. The development of quantum mechanics in the early 20th century added further layers of complexity to the study of wormholes. Researchers like Kip Thorne, a theoretical physicist at Caltech, explored how quantum mechanics might influence the stability and creation of wormholes. In his 1994 book Black Holes and Time Warps, Thorne presented a more comprehensive and accessible explanation of wormholes, bringing them to the attention of a broader audience. By the late 20th and early 21st centuries, wormholes had firmly entered both the realm of popular science and fiction. In films like Interstellar, 2014, and TV shows like Stargate and Star Trek, wormholes were depicted as portals for space travel, sparking public imagination and further blurring the line between theoretical physics and fiction. Despite this surge in popular interest, wormholes remain theoretical, with no experimental evidence to support their existence. However, their study continues to be an exciting frontier in modern physics, raising fascinating questions about the very nature of spacetime, gravity, and the universe. 10 amazing facts about wormholes. 1. Wormholes can theoretically connect any 2 points in spacetime. The most fundamental property of a wormhole is that it connects 2 separate points in spacetime. These points might be light years apart in normal space, but a wormhole could, in theory, provide a shortcut, drastically reducing the distance between them. This means that a trip from Earth to a distant star, which would normally take thousands or even millions of years using conventional methods, could be accomplished in mere moments. 2. Wormholes might be a portal for time travel. While wormholes are usually thought of as spatial shortcuts, they could also allow for time travel. If one mouth of a wormhole were to move through space at relativistic speeds or experience gravitational time dilation, due to being near a massive object, time could pass differently at each end of the wormhole. This means that an object could enter the wormhole and emerge at a different time, potentially in the past or future. 3. Exotic matter is needed to keep a wormhole open. A major challenge in making wormholes practical for use is the need for exotic matter, a hypothetical substance that has negative mass or negative energy. Exotic matter would counteract the immense gravitational forces inside a wormhole, keeping it open long enough to allow matter to travel through. Without it, the wormhole would collapse instantly under the weight of the forces at play. 4. Wormholes could be inside black holes. One of the most mind-blowing possibilities is that a wormhole could exist inside a black hole. Some scientists speculate that the singularity at the center of a black hole, which marks the point of infinite density, might actually be a wormhole leading to another universe or distant region of spacetime. However, this remains purely speculative and presents paradoxes that are difficult to resolve with current theories. 5. Wormholes can be stable, but only for brief moments. Theoretically, a wormhole could be stable enough to allow for travel, but only if certain conditions are met. The exotic matter needed to stabilize it would likely need to exist in extreme quantities, and the wormhole's structure would need to be perfectly balanced to prevent collapse. Unfortunately, no one knows how to create or maintain such stability in practice. 6. There may be a multitude of wormholes in the universe. According to some theories, wormholes could exist naturally throughout the universe. If they are formed by gravitational collapses or cosmic events, they might be hidden within the fabric of space. These wormholes could, in theory, provide shortcuts to distant parts of the universe, though they might be unstable or too dangerous to traverse. 7. Wormholes could be used for instantaneous communication. In addition to space travel, wormholes might enable instantaneous communication across vast distances. In theory, a signal sent through a wormhole would experience no time delay, making it possible to send information from one side of the universe to the other almost instantaneously. This would revolutionize communication, allowing for real-time conversations with extraterrestrial civilizations. 8. Theoretical wormholes can be traversed by light. Even if matter cannot pass through a wormhole, light, which has no rest mass, could theoretically travel through these spacetime shortcuts. This opens up the possibility of observing wormholes in the universe using advanced telescopes, although detecting such phenomena would be exceedingly difficult. 9. Wormholes may help solve the grandfather paradox. The concept of time travel through wormholes often leads to the grandfather paradox, which asks what would happen if someone traveled back in time and prevented their own grandfather from meeting their grandmother, thus preventing their own birth. Some physicists suggest that quantum mechanics could resolve this paradox through the many worlds interpretation, in which time travel might create an alternate timeline rather than changing the original one. 10. Wormholes might not be stable long enough for travel. Even if wormholes could exist and be stabilized, their very nature might prevent practical use. The vast energies required to create or maintain a wormhole could lead to instability, causing it to collapse or implode before anything could travel through. This is one of the reasons why wormholes remain speculative. They might simply be too dangerous or short-lived to be of any practical use. Conclusion: wormholes represent some of the most fascinating possibilities in modern physics, from interstellar travel and time travel to potentially opening doors to other dimensions. Though they remain purely theoretical, they challenge our understanding of the universe and force us to reconsider the very nature of space, time, and causality. The quest to understand and possibly harness the power of wormholes is far from over, and it remains one of the most exciting frontiers in theoretical physics. Whether or not wormholes exist, their story is one of the greatest intellectual adventures in human history, intertwining mathematics, physics, and imagination in ways that continue to inspire wonder and curiosity.